Python dictionary with 10 items and one with 10 million items both find a value in roughly the same amount of time. No scanning, no shifting, almost instant either way. That shouldn't be possible with what you've learned so far. Here's the trick making it happen. Everything you've learned so far, arrays, linked lists, stacks, queues, requires either direct index math or walking through items one by one. Hash tables break that pattern entirely, and they're one of the most important structures in this entire course. Let's break down exactly how. A hash table stores data as key value pairs. Instead of finding something by its position like an array, you find it by its key, a name, a word, an ID, anything you choose. In Python, this is exactly what a dictionary is. Here's the core trick. A hash function takes your key and instantly converts it into a number, a memory address basically, using math. That number tells the computer exactly which slot to store or retrieve the value from. No searching required, the same way array indexing calculates an address directly. Because the hash function calculates the exact slot instantly, looking up a value doesn't depend on how many items are already stored. 10 items or 10 million, the hash function still runs the same single calculation. That's why hash table lookups are O1 on average, regardless of size. Sometimes two completely different keys hash to the same slot. That's called a collision. When that happens, the hash table needs a backup plan. Commonly, it stores multiple items in that same slot as a small linked list, checking through just that short list instead of the whole table. If a hash function is poorly designed and creates tons of collisions, lookups stop being O1 and start behaving like O-ween. You're back to scanning through a list. A good hash function spreads keys evenly across all available slots, which is exactly why hash function design matters so much in practice. Here's what catches people off guard. Saying hash table lookups are always O1 without qualification. That's not quite right. They're O1 on average, assuming a decent hash function and manageable collisions. In the worst case, with a terrible hash function or a table packed with collisions, it degrades to ON. Precision on average case versus worst case is exactly the kind of detail that separates a strong interview answer from a shaky one. Hash tables store key value pairs and use a hash function to instantly calculate exactly where to store or find each value, making lookups O1 on average. Collisions happen when two keys land on the same slot, and how well those are handled determines whether your hash table stays fast or degrades toward ON. This is video 12 of the full DevVerseX Data Structures and Algorithms course. Subscribe so you catch the next piece of this puzzle. Coming up, why hash table lookups are O1, going even deeper into hashing itself, explained as simply as possible.